Hello everyone, many thanks for your visit. My name is Carlos and I produce videos regularly about astronomy, about space in general. So please subscribe to my channel if you are interested and take a look. Recently I uploaded a video about the Tarantula Nebula. This is a nebula, gigantic nebula, which is about 170,000 light years away. And James Webb Telescope recently released beautiful image, crisp, clear images of the nebula. They were released on the NASA website. So I produced a video that shows you that nebula in a different light. So you can go to different areas and take a look at it. There was an image that caught my attention. It was released by James Webb website. And I didn't mention this image in the latest video. So I really like to talk about it. So let's jump into it, shall we? Okay, let me show you the image. So James Webb Telescope has an instrument mounted on it, which is called spectrograph. And this is an instrument that separates the light coming from a distant object, like a star or a planet. It separates the incoming light by its wavelength or frequency, and it plots this information into a chart, basically into a graph. So the information that is recorded on the graph is unique for each element on the periodic table. So for example, hydrogen will have a distinctive series of bright lines which identify hydrogen. So it's like a signature for hydrogen on the chart, which is different to the lines plotted for oxygen or helium or any other element. Now, scientists and astronomers can learn so much from this information plotted on the graph. They can identify the mass and size of an object. They can determine its composition, magnetic field. So there's so much they can learn. So when James Webb aimed the telescope, the spectrograph, to a region of the Tarantula Nebula, which looked like a bubble, it returned this information, this wavelength information plotted on this graph. And if you look at this photo, this image, you can see the atomic hydrogen element depicted by the blue color. It also, this region, it also has molecular hydrogen as well as hydrocarbon dust. So basically, the spectra coming from this object, this bubble, allows us to determine the composition of this area, the young stars, massive stars, that is actually producing these spectra. Let me show you a bigger version of this image. There you go. So, and what I'll do next is basically I will show you the Tarantula Nebula, and we will zoom into this area, to this bubble, so we can actually look in more detail what's going on in here. Okay, let's jump into it. This is the amazing Tarantula Nebula. If you look at the center of the nebula, and let me highlight that for you right here, you can see a massive star which has 8 diffraction spikes right there. Huge star. And to the right of the top diffraction spike, there is a little bubble, what appears to be like a bubble right there. let's zoom into it, shall we? Okay, so what we have learned from the spectrograph, from James Webb's telescope chart, is that this section in here, which is dominated by hot gases and dust, a lot of pillars of dust, this is actually gas and dust which is being emanated from a star, a young, bright star, which is at the bottom of this circle to the right. Let me point it for you. This one over here is the one causing these pillars of dust. And it's amazing what we can learn from the chart produced by James Webb. Absolutely amazing. Thanks for watching.